So today we're going to be continuing with section 3.3 and we're going to specifically look at the remainder and factor theorems. Okay, so the remainder theorem says that if a polynomial p of x is divided by x minus c, then the remainder is the value p of c. So we can do synthetic division, basically doing the x minus c, and whatever the remainder is going to be the same as evaluating the function at c. So basically, it allows you to evaluate that function at a given value using synthetic division. Okay, so first of all, what I want to do is I want to show dividing this polynomial by x minus 1 using synthetic division. So here I'm going to put 1 in the box. I'm going to have 1, 0, 0, -3, 6, and 4 as my coefficients. So I'm going to bring down the 1 to start it. So I'm going to multiply and then add, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so what I have here is this will be x to the fourth plus x to the third plus x to the second minus 2x plus 4, and then my remainder is 8 over x minus 1. Okay, what I'm focused on here for the remainder theorem is actually this remainder itself. Okay, so what that tells me by the remainder theorem is that p of 1, which is what this value is here, so p of 1 is equal to 8. So that's a little bit easier than having to go through and evaluate it here. So if I wanted to find p of 1 by direct substitution, then what I would have would be 1 to the 5th minus 3 times 1 squared plus 6 times 1 plus 4. It doesn't look so bad for 1, but if you happen to have had 2 or 5 or something, then it gets to being a little bit harder than doing this by synthetic division. But what you can see here is that you actually are going to get the same answer. So here we have 11, there'll be 11 minus 3, so we'll end up with 8. So we get the same thing whether we plug it directly in or whether we do the synthetic division. Okay, find the quotient and the remainder when p of x is divided by x plus 2. So if you would like to pause it and try it yourself, that's fine. I'm going to go ahead and work it here. So we'll put the -2 in the box. Okay, so bring the 3 down. We'll add, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so our quotient is going to be 3x to the 4th minus x to the 3rd minus 2x squared plus 4x minus 1 plus 5 over x plus 2. Okay, so that's finding the quotient and the remainder. Okay, using this same polynomial, we want to use the remainder theorem to find p of -2. Well, if we look back at our work here, that's actually what we did because -2 is here. So that's evaluating the function. So the remainder is actually going to give me the value of p of -2. So that remainder is going to be 5. Okay, so that would be using the remainder theorem to find p of -2. Okay, so the questions come up, is x plus 2 a factor? In order for it to be a factor, it would need to have divided evenly and had 0 as its remainder here. So because it did not divide evenly and it did have a remainder, it's not a factor, and x minus 2 is not a solution. Okay, so that brings us to the factor theorem. So the factor theorem says C is a 0 of P if and only if x minus C is a factor. So basically, if I know C is a 0, then I know x minus C is a factor. If I know x minus C is a factor, then x minus C is a 0. So if I know that 5 is a 5 is a 0, then x minus 5 is a factor. If I know that x plus 3 is a factor, then by the same reasoning, negative 3 is a 0. So they go back and forth. Okay, so we have this polynomial provided here. We want to show that P of 1 is 0 and then use that fact to factor the polynomial completely. So if we look at this polynomial and we were asked to factor it, we really don't have a lot of techniques from factoring to use for it. Okay, it doesn't factor as a trinomial. It's not the difference of squares. We can't use grouping. There's no GCF. So all of our factoring techniques are kind of exhausted and we can't really get started with it. So what we're going to do is we're going to use the fact that P of 1 is 0 to reduce this down to a quadratic, and then we can factor our quadratic. So because P of 1 is 0, we can put 1 in here, do our synthetic division, and we end up with 0 for the remainder. And so basically what we've shown is that since P of 1 equals 0, that x minus 1 is a factor. Okay, so that's one of our factors. We've got to finish this up and find the remaining factors. So this is equivalent to x squared plus x minus 6 if we were to just drop it down the 1 degree and write our expression. This is now a quadratic, and we know how to factor quadratics, so this factors into x plus 3 and x minus 2. So the complete factorization of this would be x minus 1 that we picked up here, and then the x plus 3 and the x minus 2 that we get here. Okay. All right, so here's one that I want us to go through. We're going to first of all show that P of negative 2 is 0. So I'm going to do negative 2 and do synthetic division. Okay, so we'll bring down the 1, we'll multiply, add, multiply, add, multiply, add. Okay, so since it's 0 for the remainder, then we know that negative 2 is a 0 and x plus 2 is a factor. So I want to take this and finish factoring it out. So this is going to be x squared plus 0x minus 9, which is the same thing as x squared minus 9. Hopefully you still recognize this as the difference of squares. So this will factor x plus 3 and x minus 3. So we'll combine it along with this x plus 2. So my complete factorization is x plus 2, x minus 3, x plus 3. Okay, if it asks for, these would be the factors or the factorization. If it asks for the zeros, then my zeros are negative 2, and the 0 that goes with this factor is negative 3, and the 0 that goes with this factor is positive 3. Okay, here's one that has 2 zeros that are provided, or at least suggested. We have to show that they're actually zeros, and then use that conclusion to find the remaining zeros. So I'm going to start here with negative 1. So to show this, what I need to show is that my remainder is 0. Okay, so I'll bring down, multiply, multiply, Okay, so what we've shown is that x minus 1 is a 0, x plus 1 is a factor. Okay, so instead of starting over back with the original, what I'm going to do is I'm going to start here with this line. So I'm going to put my 3 here, and I'm going to go again with my synthetic division. So I'm going to bring this down. I'm going to multiply. I'll add, and then I'll multiply. Okay, and so I end up with 0 here again for my remainder. So what that tells me is that 3 is a 0 and x minus 3 is a factor. And I've also now got this down to a quadratic. So I started here with a 4th degree, and when I reduced it one time, I was at a 3rd degree polynomial. When I reduce it again, I'm now at a 2nd degree polynomial. So I'm going to have 2x squared minus 17x minus 9. Okay, I'm asked to find the remaining 0. So it may or may not be factorable, but we can definitely find our remaining zeros by using the quadratic formula if we need to. So the quadratic formula is going to give me negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be 17 plus or minus the square root of 361 over 4. Okay, the square root of 361 is 19. So I end up with, if I do 17 plus 19, I'm going to have 36 over 4. And if I do 17 minus 19, I'm going to have negative 2 over 4. So I'm going to come back over this way, and 36 over 4 is going to be 9. 2 over 4 would be 1/2. So 9 and negative 1/2. So my remaining zeros are 9 and negative 1/2. If it asked me to list all of my zeros would be negative 1 and 3, which were given to me, 9 and negative 1/2. Some of you may have noticed at this point that this could have actually factored, and that would have saved us from doing the quadratic formula here. But if you don't recognize that it factors, the quadratic formula is an option. Just another comment, if it were to ask for the factorization and not the zeros, then we're going to translate each one of these into its factor. So x minus 1's factor would be x plus 1, x minus 3, x minus 9, and x plus 1/2. So it just depends on whether it's asking for zeros or whether it's asking for the factorization. Okay, so moving on here we're asked to find a polynomial of the specified degree that satisfies the given conditions. So we need a 4th degree polynomial, and we need one that has these zeros. So what we want to do is take each 0 and convert it into its factor. So I'm going to do x minus a negative 4. So that's going to be x plus 4. I'll do x minus 0, which is just x minus 1, and then finally x minus 6. So if I combine these together, my polynomial would be x plus 4, x minus 1, and x minus 6. And I'm not too concerned that you multiply this out. I'm pretty sure WebAssign will take it like this, and so as long as you can do it like that, that's fine. It does need to be a 4th degree, so you need to make sure that you do have at least 4 x's. If you were going to multiply it out, I would suggest multiplying these two and these two and then multiply it together. So that would be x squared plus 4x. And then this one's going to be x squared minus 7x plus 6. Then you'll need to distribute or do the box, whichever you prefer. So we'll have x to the fourth minus 7x to the third plus 6x squared. And then here we'll have plus 4x to the third minus 28x squared plus 24x. We'll combine like terms together. And we'll get our answer there. And I just need to make one correction here. This should actually be a cube. Just realized when I was copying that over that I had copied that wrong. Okay, last example here. Find the polynomial of the specified degree whose graph is shown with a degree of 3. So looking at this, we can see that this has the general shape of an odd degree polynomial with a positive leading coefficient. So keeping all of that in mind here, my zeros, I can read from the graph and see that they're at -2 and 1. So that means my factors are going to be x plus 2 and x minus 1. But when I look at this, if I were to multiply this out, it would be an x squared. So it would be a second degree polynomial and not a third degree. So when I look a little bit more closely, I see that the graph touches here at -2. It doesn't cross. So that tells me it has an even multiplicity. So this is going to have a 2 for its power. And then that'll take care of the third degree for me. So if I were to multiply these out, multiply this and I'll get x squared plus 4x plus 4. And then I'll multiply that by the x minus 1. So I'll have x to the third plus 4x squared plus 4x minus x squared minus 4x minus 4. So I'm multiplying everything by x and then everything by -1. So I end up with x to the third plus 3x squared. My 4x's cancel, and I'll have a -4. So that takes us to the end of this section. Be sure you're keeping up with your homework and quizzes, and let me know if I can help you in any way. Thank you and have a good day.